Day of dilation, and we're going to be working with dilating images. All right, so our first thing first is the key vocabulary word that we learned in Unit 2, which was the idea of the rigid motion. Okay, and remember that's a transformation. Now, transformation does not mean a translation. When we talk about a translation, we're talking about the idea of a reflection, a rotation, and a translation. Those are the ones that we have talked about so far. And we have to remember that a transformation that's a rigid motion is one that preserves, which means to keep, the size, the shape, and angle. Okay? So everything about it is kept the same. Now what we're really going to be talking about in this lesson is the idea of dilation. Okay, and a dilation, now when you think about that, most people think to make big, but it doesn't. It's not just big. Okay, and to make something big, we call that to enlarge it. So that word enlarge means to make big. Okay, so our image could get bigger, or it could mean to make smaller. By some factor, which we're going to talk about in a little bit, but leaves its overall shape the same. So when we're looking at exercise 1, we want to be able to look at whether these are enlargements or did the image get shrunk. Okay, so this one here is what they would call our pre-image. And after we have performed a dilation or a translation or a rotation is the image. The image is something that has happened to it. Okay, so as you see from our pre-image, it was small. 2, it got bigger, which is called an enlargement. And the second picture, you can see that the pre-image is bigger than the image. So when that happens, that's called a reduction. It got smaller. Now we're introducing an idea of a new letter. Is the idea of scale factor, which is the letter K. So that means the image is going to get bigger or smaller by something. Okay. So for example, if I measure the pre-image here, okay, we can see, oh, that's just about 2 centimeters. And if I go to the image, it almost reaches 4. So we can kind of see that it's almost twice as big. So when that is twice as big, the scale factor would be 2, because 2 times the scale factor would need to make this 4. Well, that means that the scale factor would have to be 2. Okay. So I can kind of do the same thing here. I'm going to look at kind of like the height of the tree. And if I look, the height of the tree is about 3.5 centimeters. Okay. So this is 3.5 centimeters. And then if I look at the tree, oh, it's about 2.25 centimeters. Okay. What does that mean? That means that 3.5 times whatever the scale factor is needs to equal 2.25. And what we need to do is we need to figure out what this K value is going to be. Now, that looks like a regular equation. So then I would divide by both sides by 3.5. So if I take the 2.25 and I divide it by the 3.5, I get a scale factor of about 0.64. Okay. So that means that my K would equal about 0.64. And we'll do that continuously through this lesson. We'll try to figure out what is the scale factor. Okay. So why is this so important to learn about a dilation? Well, that's what we use on our phones. Okay. When we take an image on our phone and make it bigger, or we make it larger, that is what the scale factor does, right? So if we take a look at here, we want to learn about the two things that involve a center of dilation and the idea of the dilation of the scale factor. Okay. So the center of dilation is what it sounds like. It's a point where an image is being dilated from. And we're going to look at that in the next exercise. And a scale factor is that k that we were just talking about. It's a number that you're actually going to multiply by. Now you're going to multiply either the coordinates or an actual number that they give you of a segment. And we must note that the number that you're going to multiply by must be positive. Okay. So if we think about why the number must be positive, well, that's because of that very important word, the word length. It has to be positive because lengths are not negative. We would not consider a negative length. Okay, so now looking down at the bottom, okay, on to exercise 2, when we actually talk about a dilation, we talk about C is the center of the dilation. Okay, if this is the center, this point right here, this is not going to move. It's the A that's going to move because this is the center. Now it says to use your ruler to find the image of A after a dilation by a scale factor of A when the scale factor is 2 and B when the scale factor is 0.5. And we're going to label that with A prime and A double prime. Okay, so first off, let's connect C to A. Now, if we measure from C to A, we can see C to A is supposed to be 2 inches long, right? So this line right here, the whole thing, from C to A is 2 inches. Now what I'm going to do is I'm going to make that twice as big. And I'm going to use the help of my compass and just measure that there. That's 2 inches. What's going to happen is I'm going to double that. That's what that scale factor of 2 means. It means I need 2 of CA's. Well, if CA is 2, then that means C to A prime should be 4 inches. I'm just going to extend my line out to where I just made that slight arc. But you can use your ruler and you could actually measure out 4 inches. Okay, so if I measure from here to where I got A prime to be, which is right here, here's A prime, you can see, yep, that's indeed double. I've got 4. Okay, so from C all the way to A prime, this is 4 inches. Now what happens when the scale factor is 0.5? Well, if you think about 0.5, 0.5 is another way to write 1/2 as a fraction. So I'm going to do half of CA. Well, if C to A is 2, then half of that would only be 1. So I'm going to mark that. I'm going to go halfway, 1 inch, and this would be A double prime, which from C to A double prime, it's only 1 inch. Okay, so that's essentially what a scale factor is doing. If I did half of 2, I get 1 inch. And those are the lengths that I got when I measured. Okay, I'm going to flip over to the back. And here I just have to make sure that I'm reading. Okay, so a couple of things that are important. I'm going to dilate it using A as a center and a scale factor of 2. So that scale factor of 2 means I'm doubling in length. Okay, I'm going to multiply everything by 2. So I'm going to measure from C to A, okay, which is about 3.2 if I'm looking at my ruler. Okay, so I need 3.2. So I'm going to double this and make this 3.2 as well. Okay. Right. So since this was 3.2 centimeters, if I go all the way to C prime, this then is 6.4 centimeters. It doubled. All right, so now let's measure the same thing from B to A. Okay, so from B to A, it's about 6.3 centimeters. So that means I'm going to double that. I'm going to go here. I'm going to make sure that this is going to be 6.3 centimeters as well. Okay. Now what happens if you're at home and you don't have a ruler? Well, you just pick up something that's random. And I could actually just measure this by marking it from here to there. This is the length of A to B. So then I would double that, which is exactly what I just did to my ruler. And I marked it here. And I knew to go to right there, and that's where my B prime is. So you can use other things besides your ruler. Okay, but since I did measure it, this whole thing then should be doubled to 6.3, which is 12.6. Okay, so now I'm going to do what they said to do. Connect B prime and C prime to form that. Okay. So I'm going to connect these. Okay, I'm going to leave it as that. And I'm just going to answer question B real quick. Why wouldn't A change its location after the dilation? Like, this is still A, but we have a C prime and a B prime. But why didn't A change? Well, going back up, we can see A was the center, so it should not change. So A is the center of dilation. So therefore, it doesn't move. It's the focal point. Okay. But how does the length of BC compare to the length of B prime and C prime? Well, if these multiplied by 2 to get from A to A prime, then let's look at the length of BC and B prime C prime. Well, if we did it correctly, since the scale factor is 2, if we did 2 times BC, we should get B prime C prime. Well, let me check it out. Alright, so I get B to C to be about, on my ruler that's 2.75 right here. Okay, that's 2.75. Okay, now if I did it correctly, if I multiply that by 2, I get $5.50. So this should be about 5.5. So let's see if we did it correctly. And if you look, yep, then move that down. That came out to be 5.5. So if I do 2 times the length of BC, 2.75, I get the 5.5 of BC. That means it did it correctly. So the length of BC doubles to get B prime, C prime. And that's what happens. So now this is the part in class where I give you guys the opportunity to attempt this on your own. Now remember, if it's A is the center, so that means that point A is not going to move. So that means that B is going to move. By how many times? Well, the scale factor is 3. So it's got to become 3 times longer. Okay, and again, I can use my index card. There's where B is. So I'm going to move this out. And there's 1 more. And then there's 2 more. So that really is 1, 2, 3, a scale factor of 3. So I'm going to connect it. And here is where B prime is. Now I'm going to check that with measurement just to be on the safe side. We can see that A to B is 1 inch. And if I did it correctly, it comes out to be 3 inches. So therefore, I know I'm good. I did it correctly. Okay. All right, the last one on your page is being able to, if we read it, MN is the image. Okay, if they're saying MN is the image of CD, that means CD was the pre-image. Which means that this dilation was a reduction, not an enlargement. We're going from CD to MN, okay, with an unknown scale factor. We don't know what the scale factor is, using A as the center. So you notice A is not going to move. This is the center. Okay, so we're going to use our ruler in this one. So what I need to know is what times the length of CD is going to give me MN. All right, well, let's take a look. Let's see how long CD is. Okay, it says to the nearest hundredth, so this comes out to be about 5.1. So that means CD is 5.1. Okay, so something times this, which I'm going to call K, because they call K for the scale factor, is going to give me MN. So now I'm going to measure MN, and I got 3.2 centimeters. Now this is just like solving equations. Okay, so all I got to do is, since this is K times 5.1, I divide by 5.1 to get rid of K. Excuse me, to get K by itself. Okay, so I'm going to do 3.2 divided by 5.1. Okay, to the nearest hundredth, this would be 0.63, which makes sense because the image got smaller. So if the image gets smaller, this number will be less than 1. If the image gets bigger, this number will be greater than 1. Right, so that's the conclusion of this lesson. If you need any further help, please seek me in class.